So a person tossed the coin one time. They tossed the coin one time. They got how many heads? No, none, right? Zero. Zero heads. Then they tossed it two times. So the chances are 50%. What are you noticing about these dots as I get to more tosses? They get closer to where? The middle, which is 50%. 50%, right? They get closer and closer to 50%. Are we ready, guys? Christian, are we ready? Okay. Eyes up here. Okay. I know you like Jeremy, but eyes up here, okay? All right. Here we go. So, what's happening? One more time. What's happening as the dots, as we get more and more tosses of the coin? They're going towards the middle, right? They're getting closer and closer to the middle. What does the middle represent? 50%. So when you tell me there's a 50% chance that I get a heads or a tails on one toss, there's actually not a 50% chance, right? Because a 50% chance means it's going to happen half the time. Well, if I flip a coin four times, then I should get two heads and two tails, right? That doesn't happen. If that did happen, there would be no casinos in the world because everything's guaranteed, right? That's what probability is. Probability means, yeah, sure, you know that the probability I flip a coin and get is 50%, right? Because there's two sides. But that doesn't necessarily mean if I flip a coin four times, I'm going to get two heads and two tails. Okay? That's the one thing you got to understand about probabilities. It's called the law of large numbers. Okay? The law of large numbers means the more we do something, the true number shows up. Right? We said the more we toss a coin, they tossed it 500 times. They tossed the coin 500 times. Right? And that's pretty much in the middle. Right? Pretty much in the middle. You see kind of it spikes up here. And then as I get closer to 500, about 50% of the tosses are heads and 50% are tails, which is the number you guys said. So that number you guys told me, 50% is right in the long run. In the long run. It's always based in the long run, right? Always based in the long run. So if I go to a casino and I go gamble, chances are I'm going to lose. Chances are I'm going to lose. That's just the chances, right? That's how casinos make money, right? You put money in whatever game you play. But why do I drive down Shaw? I see billboards for people who have won $10,000, $5,000, $100,000. What's that? There's always a chance, right? There's always a chance. In the long run, the casinos are going to take my money. If I play every day for a year, they're going to take my money, right? But if I go in there one time, I could win money. I could win $1,000, $10,000, $100,000, right? In one time. So one little snapshot isn't true, right? Otherwise, people wouldn't go to casinos. Why would you go to a casino if you knew you're going to lose, right? Why would you do that? Why would you give your money away, right? So that's why, right? So when someone goes to the casino and says, I won a lot of money, man, I won $1,000, $10,000, whatever they won, they're right. They're telling the truth. But what they're not telling you is the hundreds of other times they went when they lost money, right? So that's what probability says. Probability is not about a snapshot, it's about the entire picture. What happens over the course of a very long series of repetitions? So if I was to do something hundreds, thousands, millions of times, what would happen? 50% heads, 50% tails, right? If you don't believe me, flip a coin 10 times, see what happens, right? A few of you would get five heads and five tails, but most of you would get something else, 6, 4, right? 3, 7, right? So that's what we're talking about in the short term. So the law of large numbers says that if we observe something more and more and more and more, the more we observe something, the real answer, the single value, the true probability will show itself, right? So if you guys were to do this 1,000 times and I was to have a number line up here like I did, almost all of you would be somewhere very, very, very close to about 500. Because the law of large numbers says the more you do something, the more the true probability will show. Okay? That's what this shows. The true probability shows. Okay? The instability, right? Instability. Instability means up, down, up, down, up, down, right? That's instability. That fades out right around here, right? And then it starts to, okay, I see what it's doing, right? At about 1,000, it would still be right around the middle, right? Okay, so that's what the instability kind of goes away. Okay, that's the thing with probability. It's in the long run. It's in the long run. So anytime they ask you a question about probability, look for the answer that says a very long series of repetitions, because there's a question on the test, right? I'll tell you the question on the test. It says probability is A, B, C, D, E. 3 of the answers look good. You're like, oh, that's it. Oh, that's it. Oh, that's it. But there's only one answer for it. The one that is the correct answer is the one that has this part in it, a very long series of repetitions. After doing it a lot of times, that's the probability, right? The probability isn't necessarily, there's lots of definitions for it, but the true probability is after doing it a lot of times. Okay? All right, so next thing is called a simulation. Called a simulation. We're going to do one today, and then I'll have you guys do one on your own on Monday. Okay? Simulation. A simulation is an imitation of chance behavior based on a model that accurately reflects the situation. My cousin's a pilot. He used to fly in the Navy. He used to fly fighter. He was a fighter pilot, right? Like Top Gun. You guys saw Top Gun, the movie. That was him. Okay. He when he trained, it was a very long time before he got to be in one of the airplanes. He used what's called a simulator. They use simulators because those airplanes they fly some are worth $50, $100 million. One airplane, right? So if something happens to it, that's money they're not getting back, and that's taxpayer money, right? So they have to do what's called simulators. So they get into it's a big video game. They play a big video game, and it's a simulator. It simulates the actual airplane, the fighter jet. Okay, because if you were to get in an accident, something were to happen, the plane would. It's a lot of money. It's a lot of cost. Okay, so they did simulators up until they were ready to actually get in a plane, right? So they do simulations when it's too costly, takes too much time. There's reasons why you can't actually do the real thing, right? To simulate. That's why you simulate something. Okay? Okay, so here's a situation. The chance of contracting strep throat when coming into contact with an infected person is estimated to be around 0.15, around 15%. So if you were healthy and you came in contact with someone with strep throat, there's about a 15% chance that you'll get sick. Okay? So suppose 4 children of a family come into contact with an infected person at school, at the store, wherever. We got to conduct a simulation to answer the following questions. The questions are down there. Okay? So we're going to do a simulation for this. The reason I chose this one, it's not about COVID, but it's very similar to COVID, right? When COVID hit a few years ago, even now, well, how contagious is it? Do I have to be worried? What's going on? We had to know things, right? So they did simulations like this to show, right, how contagious it was. But they didn't actually do it for real. Why would they do it for real? Why wouldn't they do this for real to see if it really is a number? To see what the real number is. Why wouldn't they really give people strep throat? It's a disease. Yeah, it's a disease. They don't want to give it to them, right? So they use simulations to decide how fast is it going to spread, right? How fast is it going to spread, right? Same thing with COVID. Same thing with COVID. They did the same exact thing, right? So this one's just strep throat. Strep throat's bacterial. So it is contagious, super contagious, but it's easier to contain because bacterial, you just take antibiotics and you're good. COVID was a virus. Viruses, you can't kill viruses. You can slow them down, but they got to do their thing. That's why COVID took so long, right? Because COVID is a virus. Any virus, it's just got to do its thing. You can help the symptoms, but you can't really kill it. Bacteria, you can. Strep throat is a bacteria. Okay, so strep throat is about 15%. Okay, so this family has 4 children. They come into contact with an infected person. What are the chances that one of them gets strep throat? Yeah. What is it? 15%, right? 15% each, right? So does that mean out of 100 people, 15 will get it? No, it's just an average, right? At an average. Out of 1 million people, I would expect around 15%, right? But in the short term, not necessarily. So we want to do a simulation for lots of families to see how many would get it. What are the likely that someone in the family would get strep throat? Okay, so we're going to do what's called a simulation. We're going to do 20 trials. 20 trials. Okay, there are 5 steps for a simulation. First step, assign digits. Second one, when do I stop? Third one, actually do one trial, one repetition, one trial. Fourth one is actually doing it. Okay, so do however many they want you to do. Okay, and then your conclusion or answer questions. Okay, what's that? Yes, that'll be part of the process. Okay. All right, so let's do one round for assigning digits. Okay, so we need to assign digits for if whether they get the disease or they don't get the disease, right? So what digits can we assign to getting the disease and not getting the disease? What digits can we assign?
1 to 5 to getting it.
So 1 to 5 to get it. Okay, let's see. 1 to 5, they contract it, and then what would be the not getting it?
Or we can do 0 to 4 and then 5 to 9.
So 0 to 4 and then 5 to 9, right? Okay, so we're using 0 through 9. So how many numbers are from 0 to 4? From 0 to 4. Yeah, I heard that too. He said 3. From 0 to 4. From 0 to 4, how many digits are there? What was that? There's 5, right? Why would I say 0 if I don't want you to count it, right? Okay, so 5 to 9, how many numbers? 5, right? So there's 5 in each. So what percent? It's a 50-50, right? Is that the chances of getting the disease? No, right? So we're not going to use these numbers. So let's use numbers that will simulate 15% and 85%, right? 15% is getting the disease, 85% is not getting the disease. Let's say, okay, so let's see. 0 to 15 for getting it. So let me write this down. 0 to 14 for contracting and then not contracting. Let me write this a little bit. The rest up to 99. 0, 0 to 1, 4. So how many numbers are from 0 to 14? 15, right? How many numbers are from 15 to 99? 85. 15 and 85 make 100. Together they make 100, 15 of which are contracting, 85 of which are not contracting, right? That matches the 15%. That works. Okay? You're trying to make 15%. How can I make 15%? Well, that's one way. That works. Okay? 2 digits at a time. So we're going to go, okay, so now is our stopping rule. Okay? So let's say I pick a random number. Let's say I pick a number. So we're going 2 digits at a time. So let me put that 2 digits at a time. What if I get the same number twice? So what if I get the same number twice before I'm done? Is that okay? Or do I need to skip any repeats?
Skip, skip.
So what does a repeat mean? A case of a disease, right? So it's okay to repeat. It's okay to repeat numbers. You don't need to skip, right? The only time you skip is it when it talks when the number is a person or a thing, right? This is a disease, so we don't have to worry about that. So no repeats are okay. So if I get the same number twice, it's okay. Okay. When do I stop with one trial? Because it said I got to do 20 trials. When is one trial done? Because it's good to know when one trial is done, because then I got to do it again and again and again. So when is one trial done? Not necessarily, because I am going to get a zero number between 0 and 99. But when am I done with one trial? So go back to the question. Four children, right? When I've gone through all four children, right? So when I've gotten four numbers. So every four numbers, I'm going to stop because that represents one family. Represents the family. Okay. So every four digits, I should say digits, not numbers. Every four digits. Okay. Hmm? Say it again. Say it again.
Yeah, 4, 2.
So every 8 digits, I should say. So every four groupings of 2 digits. Because yeah, 2 digits does sound bad because that's only two kids I would go through. So yeah, so let me rewrite this. So four. Yeah, let's just go back to numbers. Okay. Okay, so now we're gonna do one trial. Okay, so I need to represent each kid. I'm gonna go 1, 2, 3, 4. There's each kid. Right? Now you're gonna go to your table, your random digits. I gave you the random digits, so you don't have to use your table. I gave you the random digits. What is the first number, 2-digit number I come across? 31. No, yeah, the first 2-digit number is 31. That's the first kid. So does the first kid get the disease or not get the disease? Not, because it comes between 15 and 99. Good. So here we're going to write not contract. NC for not contract. Okay. The second 2-digit number is 15. That represents, it's close, but still not contracting. So far the first 2 kids haven't got sick. The next 2 digit is 1 with 6, 16. That is not contracting again. Okay. And then the fourth 2 digit number, 47. Not contract. So the first trial, no one got the disease. Okay. That's what we said. That was our stopping rule. Every 4 numbers, every 4 2 digit numbers. That's what I should have put. Okay. Every 4 2 digit numbers. 1 round is done. Okay. No one got the disease that time. So now what you're going to do is you're going to do it 19 more times. It doesn't take as long as you think. I went really slow. You guys can do this pretty fast, right? But what I need to do is have a scoreboard of what's going on, right? So the scoreboard can be designed however you want it. I'm going to do the first one for you guys. Okay. On Monday, when you guys come back, I'm going to have you guys do your own. Okay. So the scoreboard, I need to know how many kids get sick every trial, right? That's what I need to know. How many kids are getting sick every trial? So my scoreboard is going to look like this. 0, 1, 2, 3, 4. Can't have negative kids sick. Can't have more than 4 kids sick, right? So every time I run a trial, I'm going to put a little tally mark. Number of kids sick per trial. Okay. So the first one I did, there were 0 kids, right? So I'm going to put a tally right there. I'm going to do it again now. 1, 2, 3, 4. Trial number 2. Pick up where you left off. Don't start from the beginning. Pick up where you left off. So the part I left off was 27. So 27, 88, 79, 53. That's my next 4 kids. 27, no contract. 88, no contract. 79, no contract. 59, no contract. So no one got the disease again. So I'm going to put another tally mark there. Okay. I'm going to keep doing that until I have 20 tally marks. Okay, 20 tally marks. You all should have the same tally marks because you're using the same table and you're using the same rule, right? You have the same digits assigned. You have the same stopping rule. You have the same everything. So everyone should have the same number so you can check. So that's why I did it this way. Okay? Okay. So do it. Keep doing it. Okay. So we're going to use that to answer the questions at the bottom. It's not hard to answer the questions. It's our conclusion is these questions. They'll always have a question. That'll be our conclusion. Whatever the questions are, answer them. Okay. So there is a blank percent chance kids 0 kids. Well, 0 kids are here. So 11 out of 20 is 55. 1 kid I had 8 times. So was that 40?
Trial with 2 people.
What's that?
I think there's a trial with 2. What's that? Contaminated people.
Which one? Where was the 2?
I think it's trial 11.
What's that?
Trial 11.
Try 11. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. Oh, I missed these numbers. That's why I missed these numbers. I totally didn't see these guys. So yeah, mine's gonna be a little, yeah, mine's gonna be a little bit off from yours. It's okay. It's not that I used bad. I just didn't see them. Okay. So yeah, it should have been 49. Yeah. So okay. So based off my numbers, your numbers are going to be different. Your table's going to be different because I messed up. So there is a 5% chance and 0% chance. Okay. Okay. So on Monday, you're going to do your own. Right. All right, guys. I'll see you guys on Monday. See you on Monday. Have a good weekend.